Hello guys, we are back with our next lecture. In this lecture, let us go through the concept of segmentation, guys. So in the last few lectures, we have clearly discussed all about paging, right? So the only disadvantage which we are left out with the paging is it is not that much concentrating on internal fragmentation, right? So there is a chance that internal fragmentation could occur. So now what the segmentation told that is so segmentation is another process. So it told that I am going to solve the internal fragmentation and it is coming like a hero now. Okay, so what is the concept of segmentation is so assume that we wrote a code, guys. So understand the concept, guys. We rarely see a question on segmentation, so that is the reason why I'm also not going to go in detailed about it. So we'll be just taking the overview of it. Okay, yes. Okay, so segmentation says that, so I am going to take care of internal fragmentation, you don't worry. You paging, you are not that much smart, I am too smart, it will be thinking and it will be coming. Okay, yes. So what segmentation does is, so if you wrote a small block of code, so your code will have various things, right? So it will have some functions. So it will have the main function, or the main thing which we say like void main, we will be writing the main function, right, where the program will start, and you will have multiple functions in this program which it is calling, and there could be some symbols which you are using, there could be some variables, there could be some functions, there could be some predefined things. So there are various things which will be covered with that particular program, right? So what segmentation does is, so it is going to break your code into some small chunks. Like main program is a part, symbol table is a part, stack is a part, subroutines are a part, square root, if assume that square root is a function in your code, so that is a part. So these functional codes, it is going to give the exact spots for them. So with this understanding, I think everyone can 100% surely say that there is no chance of internal fragmentation, right? Because it is giving the exact slots, means it is indirectly working as a variable sized partition, right? Yes. So segmentation is a memory management scheme that supports this user view of a memory. So basically it is going to go up to user. So it is taking the inputs from the user, right? So how his code is looking. So based on that, it is storing the things, right? Yes. So a logical address space is called as segment. So each and every block here is called as a segment, guys. Okay. So for each and everything, we are going to have the segment number and the offset variable length. So up to where the storage will be going. Okay. So basically, if you recall, this diagram looks a bit similar, right? So that is the reason why I told you this is something like the variable fixing the variable storage. Okay, yes, and this almost works similar to contiguous memory allocation also, because we are going to use a limit and base, and based on those things only you are going to go where based on the requirement. So CPU will generate the S and D, guys. So S is nothing but the segment number. So you are going into the segment table. Okay, segmentation table. Okay, so I think it will be better if I go through an example, right? Yes. Okay, so I'll be taking an example, guys, so don't worry. So first of all, let us clear the definitions of limit and base, guys. So if you recall, we already know what is a base and what is a limit, right? So base is nothing but the starting address, right? So where exactly your code is located in our physical memory, at what location. So that is nothing but the base, and up to where it is stored is the limit, right? So how much a chunk it is taking place. So that is nothing but the limit, right? Yes. So I think these two definitions are clear, right? Yes. So let us take a small example, guys. So assume that we are having 4 different chunks, guys. So the first one, limit, okay, and base. So let us write down this table. Okay, so this started at 1000 and it is going up to a base of 1400. So 400, 6300. Similarly 400, 4300. Similarly 1100, 3200. 1000, 4700. So what exactly is happening here, guys? So the first part, so assume it has multiple things, guys. So assume this first guy as a subroutine, the second guy as a stack, the third guy as a square root, the fourth guy as a system table, symbol table, the fifth guy is a main program. So these are the exact slots which they have given. So basically from these understandings, what we can say, so basically this first part started at 1400, the base value, and it continues up to 2400. When it comes to this, it starts at 6300 and it ends at 6700, and this starts at 4300 and it ends at 4700. Similarly, this starts at 3200 and it ends at 4300. 4700. Similarly, this starts at 4700 and this ends at how much, guys? 5700. So this is the structure, guys. I think everyone can fill this columns based on this structure, right? Yes. So it's quite easy, right? Yes. Okay. So that in this way the segmentation is going to fill the data, guys, and whenever you are required to get a particular data, so you are going to say the segment number, guys. So assume that this is 1, this is a 2, this is a 3, this is a 4, this is a 5. So in this table you are going to have that particular numbers, guys. Okay, and whenever you say that particular number and when you say the line number, so line number, assume that we are going for third one. Okay, so let us take 5 only here because I wrote 5, right? So fifth one, and I assume that I want to search for 111 line. So what it will happen, so 5 means what it is in this 5, guys. So it is going to get the output as a 4700. So in 4700 I am searching for 111 line, so it is going to 4700 plus a 111. So it is nothing but 4811. So at this line it will stop. So basically the same concept of error. So basically if you got a particular value, so assume that in this you are searching for 1500 line. So does it exist, guys, in fifth one? No, because at max your value could go up to 1000, right? So with that understanding you can clearly say that this address is not possible. So at that time you will enter into the trap, or else you will add your result with our base value to get the final location. So in this way it will work, guys. So with this flow I think most of the students are 100% related towards the traditional contiguous allocation, right? Yes. So it's almost similar to that only, to be clear, right? Yes. Because here we are making it into chunks and based on those chunks we are storing, right? Yes. But the funny thing here is, so segmentation came like a hero and he worked with internal fragmentation safely, but he ended up bringing back the external fragmentation, right? Yes. So that is the reason why this segmentation is not that much taken care when it comes to this concept. And if the examiner wants to ask a question on this, he should give this whole table and he should explain the things, right? Yes. And if he even gives the things, we can directly, based on the value which he is saying, we'll compare it with the limit and we can directly say the answer whether it is possible or not. So that is the reason why most of the time we will not expect a direct question from this particular topic. So if there is a question, there could be some theoretical question like segmentation, does it remove internal fragmentation or does it remove external fragmentation in that way, true or false or some other thing. Okay. Yes. So now I hope everyone got a clear idea with respect to the basic concept of segmentation. So in the next lecture, we'll be discussing the concept of a segmentation with the paging. So this is a good approach, guys. Okay, because it is going to combine both of them. Okay. Yes. So I hope everyone got a clear idea on this, and next lecture will also be really a short lecture, guys. It's also going to be a short one. So in the next lecture, we'll be discussing about segmentation with paging. Okay. Yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.